Assalamualaikum, Madam Hafawati. In this video for group assignment, we will be presenting the topic on application of differentiation. Before we start, I would like to introduce the group members. Hi, I am Azati Nabila and my group member is Nur Aimi Afika. First of all, the introduction of application of differentiation. Related rates are rates of change associated with two or more related quantities that are changing over time. Related rates help us to determine how fast or how slow a certain quantity is changing using the rate of change of the second quantity.
For example number 1, cone problem. A conical water tank with vertex down has a radius of 15 meter at the top and is 29 meter high. If water flows out the tank at rate of 40 meter per minute, how fast is the depth of the water decreasing when the water is 60 meter deep? Let's unpack the question statement.
We are given information about the size of the cylinder and the rate in which water flows out. dV over dt is negative 20 meter cube per minute. The reason why the rate is negative because water level is decreasing. What is the rate constant of height dH over dt when h equals to 16 meter? We already have the rate of the change, volume of the water flows out, dV over dt. So the only thing that we need to find is dH over dV. Since we are dealing with volumes and cones, it will be wise to use the formula for the volume of a cone, which is V equals to 1 over 3 pi r square h. In order to get the derivative of volume of a cone, we need to express V in terms of h, so the variable r must be eliminated by isolating it. After that, substitute the R in the volume of a cone equation. We will get 25 over 432 pi h cube. Then we differentiate the cone volume.
Referring on this formula,
get 25 over 144 pi h square. Now, taking the derivative of this will give us 1 over 25 over 144 pi h square times negative 20. We will get negative 20 over 25 over 144 pi h square. Filling in all the information we have to the differential equation. We have h equals to 16. So dh over dt equals to negative 20 over 25 over 144 pi 16 square. We will get negative 20 over 400 pi over 9. And then negative 20 times 9 over 400 pi, and the final answer negative 9 over 20 pi.
Let's go through for the example 2 ladder problem. A 10-meter ladder is resting against the wall. The bottom is initially 6 meters away from the wall and it's being pulled away from the wall at rate of 0.05 meter seconds. How fast is the top of the ladder sliding down when the bottom of the ladder is 8 meters away from the wall? From the given information, we get the ladder size and the rate of which the ladder is being pulled away from the wall, which is 0.05 meter second. So we need to find the rate of change in which the ladder is sliding down from the wall when the bottom ladder is 8 meters away. We can say that dw dt is equals to dw over df times df over dt. We can find the variable w using Pythagoras theorem, since the picture we drew was a triangle. B square plus c square equals to a square. You can say that b is w and c is f, and also a is the ladder size. So we fill all the information that we get from the question, which is w square equals to 10 square minus f square. So the final answer is w is equals to square root 100 minus f square, or we can say that 100 minus f square power of 1 over 2. So now we need to differentiate the w variable to find the rate of change w over df. Using this formula, 1 over 2 times 100 minus f square power of negative 1 over 2 times with negative 2f. So the answer is negative f over square root 100 minus f square. The last step is plugging everything that we have found in the formula that give us negative f over square root 100 minus f square times 0.05. So it will be 0.05 f over square root 100 minus f square. When f equals to 8, we just need to replace f to the number 8 into the formula. Negative 0.05 times 8 over square root 100 minus 8 square. equals to negative 0.4 over square root 36. The final answer is negative 1 over 15.
To sum up this presentation, we see how essential derivative rules are in word problems that involve quantities, rates of change. In fact, related rates will help us when we want to solve problems that involve two or more related quantities that are changing over time.
That's all from us. Thank you.